Okay, we are doing two-lane highways, and yesterday we did this example. Not yesterday. Yesterday, yeah, we did. Yes, you didn't. We did. Okay, so if you see the video of this example, you will find that I only did one direction. Okay, and I advise you to do the other direction more so in your section because you didn't do even the first one as well. So you should check it out. Moving on. This is how we calculate the capacity of one direction of a two-lane highway. Okay, so this 1700, I mentioned it earlier as well. This is the maximum flow in one direction for two-lane highway. Okay, and how do we define capacity? What is the definition of capacity? Maximum volume, because I said flow now. So maximum, right? And 1700 is also maximum. So what's the difference between C and 1700? Say again. These factors, right? Okay. So 1700 is ideal. Okay, 1700 is ideal. You cannot reach ideal because then we have the heavy vehicles and these things. Okay, so FHV is the heavy vehicle factor. Okay, and FG is what? Gradient factor. Okay, now this factor has a table. It has 3 tables. Okay, if you go to the tables, then we need the terrain. Okay, so we can know the terrain, no problem. But then we need the flow as well. Okay. So we are calculating capacity. I will take this factor and put in the equation of capacity. Okay. So we said capacity is what? Maximum flow. So which value I will take from here? Maximum. Clear? Okay. In the capacity equation, you need Fg. When you go to the Fg tables, you need flow. You take the value which is for maximum flow, because capacity means maximum. Okay, so you see this table, and this table is for gradients. Again, you will take the value which is for the maximum flow. Clear? Clear? Any questions? Questions? Okay. We have this example. Class 1, 2-lane, 400 meters per hour, both directions, current, 15% trucks, 2% RVs, we'll combine them, total 17%. Okay, these are heavy vehicles. 60-40 split of traffic, one direction has 60, other one has 40. Peak hour factor 0.84. Okay, we are required to do 2 things. First of all, find out the capacity. Okay, capacity in terms of flow, capacity in terms of volume. Capacity in passenger cars per hour, capacity in vehicles per hour. Okay. And then we have to find out when we will reach the capacity. Okay. This is the equation of capacity, right? Okay. The first thing I should calculate is what? Gradient factor, okay, fine. Now for gradient factor I need the terrain. Okay, is the terrain given here? No, it should be, so I'll assume now. Okay, I need the terrain, I will assume level terrain. Okay, it should be given. So if I go to the level terrain Fg column, this is it. Okay, and I will pick what value? The maximum, which is the value which is for maximum flow, which is 1. So Fg is 1. Okay, it's gone. We are multiplying, Fg is 1. Don't have to worry about it. Clear? Next thing. Have adjustment for heavy vehicles. It has an equation. We have used it earlier as well. I will write the equation over here. So FHV equals 1 divided by 1 plus PHV EHV minus 1, and what happened to minus 1? Okay. PHV, how much? 17, trucks plus RVs, okay, 17%. EHV again depends upon terrain. Terrain we have assumed level. For level terrain, EHV is 2. Okay. From where did I get it? There's a table for that. Okay. In the last topic, there's a table. Then go and check. Right now, just believe me. So EHV is 2. And PHV is 17% given. So FHV is 0.85. So now capacity is 2. I wrote what? 1. Okay. You took 2 or 1? What? Yes. 2. I'm asking 2 or 1. You are saying yes. Ready? 3, 1. How much is capacity? Okay, fine. It will not be 1. 1445. Okay. This is vehicles per hour. This is vehicles per hour. Flow rate, maximum flow rate in vehicles per hour. Okay. Maximum flow rate for this highway in vehicles per hour. If I want to convert vehicles per hour to passenger cars per hour, what do I do? Say again. How? Which factor? Yeah, this. Okay, FHV. Now you multiplied with FHV, right? Right now you multiplied with FHV. So it became what? Vehicles per hour. If you divide, it will become passenger cars. Got it? Okay. So if I take this value 1445 divide by FHV, what it will become? No, value. 1700, right? Because we multiplied 1700, it become 1445, right? If we divide by 0.85, it will become 1700 again. Because FG was 1, right? FG is gone. We didn't do anything with FG. Okay. So this is capacity in vehicles per hour, and this is in passenger cars per hour. Clear till now? Okay. Both these terms are flow rates. Both of them are flow rates. 1445 is also maximum flow rate. 1700 is also maximum flow rate. Okay. The units are different. How do I convert flow rate to volume? Multiply by peak hour factor. Okay, peak hour factor is given here 0.84. Okay, so I'll multiply both values by 0.84. How much? 1 to 1 3. Okay, and the other one 1700. Okay, this one in passenger cars per hour and this one in vehicles per hour. Sorry, the other, yeah. This is vehicles per hour, and this one is passenger cars. Clear? But both of them are volumes. Maximum volume in vehicles per hour, maximum volume in passenger cars per hour. Got it? Okay. First part done. First part is done. But the important thing to note down here is you must know what each value means. Otherwise you cannot do this. You will be looking for equation, there is no equation. Okay. If you don't know what is heavy vehicle factor, you don't know what peak hour factor means and what does it do, there is no equation to make you do this. Clear? Clear? Okay. Second part. If the traffic grows 8% every year, in how many years it will reach capacity? Okay, what is the current traffic? 400. Okay, but this is 400 total. 400 total. Okay, and normally then this is the volume. If something is given like this in vehicles per hour, this is the volume. Okay, so they gave me total volume. Okay, in vehicles per hour. Clear? Okay. What do I have? This is what? Volume per lane for one direction. This is volume, maximum volume for one direction. Okay. So first of all, I will break that value, which is total, into each direction. Okay. The directional split 60-40. Okay. Which direction will reach capacity first? 60%. Okay. So how much is that? How much? Huh? Okay, to reach capacity, this 240 will increase 8% every year, and then in some years it will be equal to 1213. Because this is in vehicles per hour, so I will compare with vehicles per hour, so 1213. Got it? Okay? Okay. So we have an equation, right, to calculate the future value. We used it in the previous topic as well. So I need the present value 1 plus I to the power n. We used it in the previous topic, right? Sure? Maybe I'm lying. We used it or not? When is the exam? 12, right? This is the most important thing, right? When is the exam is the most important, right? I can give whatever I want. Huh? What? It's included, okay? I joke, I don't die. It's included. Okay. So what future value I am looking for? 1213. What is my present value? 240. What is my growth rate? 8%. I am looking for n. How much is n? 21.06. Okay. So in 21 point some years, it will reach its capacity, and then what will happen? What will happen? After capacity, what happens? Level of service? F. Okay. After capacity, level of service? F. Clear? Okay. So we found the capacity in flow rate, in volume, in passenger cars per hour, in vehicles per hour. Okay. And then we found in which year the current traffic volume will reach this value. Okay. In the peak direction. The peak direction is done, then the highway is done. It reached F, that means the highway has F. Clear? Okay? Everything which we did now, everything, apart from FG value, which I took from a table, everything else is from the previous topic. What is capacity? Previous topic. What is FHV? Previous topic. Flow rate to volume? Previous topic. Everything. Okay? Clear? Just trust me. Okay. The next thing we will start is traffic control devices. It is from chapter 4 and 18 of the textbook. 4 has some basic topics and basic concepts, and 18 has more details about traffic signals. So what is a traffic control device? It's the object through which you communicate with the driver. Okay, the object through which you communicate with the driver. Okay, so you are angry, you are honking the other driver. Okay, or you are coming from behind and you start flashing. That is not the traffic control device. That is your madness. Okay, these are the objects through which the government will communicate to the drivers. Okay, the traffic departments, traffic directorate, the Ministry of Works, Ministry of Transportation, these nice people. Okay, not you guys. Clear? So there are 3 types of traffic control devices. We have traffic markings, traffic signs, and traffic signals. The standards for designing the device, there is a specific manual which we use for these devices. The name of the manual is Manual on Uniform Traffic Control Devices. Okay, what's the name? And the short form is MUTCD. I know you are very innovative with the short forms. According to them, MUTCD means Manual on Uniform Traffic Control Devices. Okay, according to you, whatever. Okay, what happened? Why are you going down? Getting old, huh? Okay. So what does this manual cover? It covers application of the device, where the device should be used, in which situation, which condition. So there are standards to follow. When you are thinking about putting a signal, you have to follow some conditions. If you fulfill the conditions, then you can give a signal. Same thing for roundabout, same thing for a speed limit sign, same thing for a stop line, and so on and so forth. Okay, there are conditions which you need to follow, and these conditions are mentioned in the manual. Okay, and one thing which I mentioned in the previous topic with 2-lane highways, that was if you have a class 1 highway, then the markings and signs are more important because of the high speed. Okay, so this is one of the examples for the things which I mentioned in the manual. Design of the device. Okay, so the height, the width, the color, the legend, okay, the font, everything. So this is covered by the manual. Okay, and the last thing is placement of the device. So you decided in this condition I need a device. I need an object to be placed. But where would I place it? On the pavement, on the side of the road, top of the road, okay? Or I just throw it on the car, whatever. Okay, so these things. The manual is published by Federal Highway Administration. The last edition is available. It was uploaded on 11 December 2023. Why do we need the manual? Why do we need any standards? For uniformity. So everybody is doing the same thing. Everybody is following the same approach. Okay, so the main item is uniformity. Why do we need uniformity here? Okay, we went to the site visit, right? Okay, and you may have gone to other site visits as well. So when you go to the site visit, what is the first thing they tell you about? The first thing when you go to the site, safety, right? Safety, okay? And if you see the different safety mechanisms at different sites, they are the same. They follow the same symbols, the same colors, okay? So again, they are following what? Safety. In safety, they are following, like they are keeping uniformity. To maintain safety, they need uniformity, okay? The critical aspect about traffic safety is time, okay? So they were talking about safety, you were taking your selfies, okay? So you didn't listen, okay? Okay. So you didn't listen, okay? So you see some object on the site and there's a symbol on it, you don't understand, okay? So you can stand here, look at it, ask someone before you go on. You can do this, okay? But what about if you are driving? Can we do this? Huh? No. Drive, okay, on the side or outside. Can we do this for a traffic device? Stop there and ask? We can, right? We should not. You can, but you should not. Okay? Till you have the final exam, don't do this. Okay? So, the important aspect is time. The driver has a fraction of a second to look at the device and receive the message. Okay? And now we have less time because we have to look at other things, right? Like what notification popped up from Instagram and what my friend is saying on WhatsApp. I have to look at all these things, right? Okay. Some people were calling me yesterday. Like, I'm driving, trying to reach the site. They're calling me. We are here, where are you? Okay. So, uniformity will make sure the driver gets the message as quickly and as clearly as possible because he is looking at the same thing again and again. Okay, so this is why uniformity is important. Uniformity is because of safety. Okay, we want to maintain safety. The information we are trying to provide is important. So we don't want the driver to get confused or take more time in reading it. Okay, there is no time. Okay, so that's why we need uniformity. The things which are covered in the manual I already mentioned. If you want to provide a device which is effective, an object which is effective in communicating the information, you should fulfill these requirements. The first requirement is there should be a need for the device. There should be the need for the object where you are putting it. Okay, take the example of a stop line. Where do we need a stop line? Intersection. Okay, so a stop line is only provided where the vehicles are supposed to stop. Clear? Okay, you cannot put a stop line anywhere you want. Okay. So there should be a need for it. It should command attention of the driver. So it should be clear, big size, no restriction, easy language, and so the route which you take to your home, the very obvious example is the signs which are showing directions. The big signs on top of the road, right? Especially on main highways. Now you don't want to look at them because you know where you're going, hopefully. but still you see them every day. You cannot miss it. Get my point? You cannot miss it. Like you are driving on the same highway every day, you know where the left turn is going and the right turn is going. You are not interested in reading the sign. But if you are looking ahead, it will come in your vision, right? Okay, this is what we mean by commanding attention. It pops up. Okay? Convey a clear and simple message. The message I already mentioned, there is not much time with the driver, so the message should be very clear and simple. Okay? One piece of information per object, not more than this. One piece of information per object. Okay? Let us take the example of a lane which is for left turning. I want to show the driver, if you are going to take a left turn, be here. This is your lane. Okay? So I use two objects because I want to show the driver, this is your lane and this goes left. Two things, right? Where is the lane and where is it going? So I use lane marking, one object, one device. And then for the direction I use the arrow. Got it? I don't put the arrow with the marking. It can get confusing, right? So we don't do this. Same thing with the speed limit. You just see a number, right? You don't say accelerate, decelerate. Okay. Same thing with the sign which says signal ahead, signal 200 meters and so on. We don't ask the driver to do anything. That is informing him. Okay. So we don't want to give too much information. Again, so the message is what we are trying to give. The message which we are trying to give is very clear and simple. Yeah. Okay, command respect of the road users. Okay, so commanding respect is connected with the first three terms. Okay, what does it mean? The driver should see the need of the device, or when the driver requires the device, it is in front of him. Okay, we had an expert from US, he came to Pakistan, and he told us that the main reason of the traffic in Karachi is insane, it's mad. Okay, so nobody knows where they are going. Okay, so he told us that most of your problems will be solved if you put the lane markings properly. Okay, the lane markings are gone. Once they are gone, then don't put it again. They don't repaint it. Yes, the maintenance is very bad. So he says that because even if somebody wants to be in their lane, where they are supposed to go, they don't know. Okay, so if you put the lane markings, then at least you are asking the driver, you should be in this lane, or this is your space. Okay, so the drivers are more likely to follow it if they see it. Okay, so this is what? Command attention. Okay, that the lane marking is clearly in front of me. Okay, then there are more chances I will follow it. Okay, so you have a speed limit sign or the sign which says reduce speed. Reduce speed for what? Is there a curve? Is there an intersection? Is there a pedestrian crossing? Is there some construction work going on? Nothing. So maybe for the first time, out of confusion or out of curiosity, I may reduce my speed. But next time I will not. If I don't see anything, if I don't see the need, I will not do it, right? Okay. So commanding respect is related to the other three items, that when the driver needs the sign, the driver needs the object, it comes up in front of him. Clear? And the driver knows that if I don't follow it, something will happen. Okay? Like the stop line on the intersection. I'm looking to stop now. This is an intersection. I'm looking to stop. Okay? So the stop line comes in front of me. Okay. Giving adequate time for proper response. Again, take the example of the stop line. I'm coming at 60 kilometers per hour and I need to stop. Okay? To stop, I need 50 meters, let's say. So the stop line should be visible from how much? 50 meters. Okay? Clear? You are asking the driver to reduce his speed because of a curve. So he's coming at 100 kilometers per hour. You're asking him to go at now 80 kilometers per hour. So he should be able to see the sign before the curve. How much before the curve? the time which he needs to go from 100 to 80. Clear? Okay. One thing which you have to keep in mind when you are communicating is the redundancy aspect. Okay. They call it takrar in Urdu and Arabic both. Okay. Redundancy means what? Takrar, I know. But what does it mean? Repetition. Okay, repetition. Okay, so we have to repeat the message. But how do we repeat it? A guy is going at 100 kilometers per hour. More than one place? Yes, we can do it. So you can have multiple signs, and this is why we put the sign for signal ahead. Okay, signal after 200 meters. Okay, so we can do this, or we can do something with the design of the device. So any aspect of the device he is looking at, he will get the information. Okay, for example, red color. Red signal is for what? Stopping. So the stop sign is also red in color. Okay. Just by looking at the color, he knows that's supposed to be for stopping. Even if there's no letter on the sign, okay, you missed the letter, or the paint is gone, or there because of weather he cannot see the text, but he knows the red color means for stopping. Even the shape of the sign is circular. Okay, so you see the signal light is also circular. Okay, so any red circular object, that means stop, right? Okay, yeah. So different aspects of the object are conveying the same message. Okay, you see triangular signs for what? Triangular signs are for? Yield. Okay. Anybody else? Giving way. Okay. Triangular signs can be one of them. Yielding, yes. No, those are not triangle. The triangular sign. Haven't seen it. They are all saying the same thing in different words. Any other thing. Give way, yield, right to others, yes, all mean the same thing. Very good, you are on the same page. Good teamwork. Now give me another example. So it's like a sign to now go carefully. Okay, so sometimes they write bumper, sometimes they write yield. Okay, sometimes they write give way. Okay, sometimes the sign says construction ahead or work ahead. Okay, or they have people who are doing something with the tools and so on. Okay, but the sign triangular shape means now you have to drive carefully. Whatever is written, that's something else. Okay, so the shape, if you see the shape, then you know the sign, what the sign is about. And if you don't see the shape because of some reason, but you read the text again, you don't remember that shape. The triangular sign means careful, I don't remember, but I can see the text, right? So both things are saying the same thing. Another way of doing redundancy is using more than one objects for the same message. More than one object. Okay, not the same object again and again, more than one object for the same message. For example, left turning lanes. You want to separate the straight and left turning. Okay, so we have a separate lane for them with an arrow, right? Then you put a traffic island between the two lanes. Okay, so you see the island, now you know I have to be on this side or this side. Okay, the arrow is also saying the same thing. You want to take a left turn, come on this side. Then you see a separate signal just for left turning. So you see the signal, you know now my signal is different, that means I should be on one side. Clear? Okay, so the signal and the marking and the island are all saying what? Be on the left side if you want to take a left. Got it? So same message, different devices. Clear? Okay. So I told you there are three types of devices. The first one we are going to cover is traffic marking, which is the most common one. This is the most widely used traffic control device. We have three types of markings: longitudinal, transverse, and object markers and delineators. Longitudinal means what? Which markings are longitudinal? Huh? Between the lanes. Okay. Anything else? The shoulder. Huh? Arrows. Yes. Okay. So you get the idea. Okay. The shoulder, the lanes. Okay. The edge of the road, white lines. Okay. All these are longitudinal. Transverse. Huh? Stop line. What else? Huh? Traffic light is a sign. It's a sign that you don't know. Huh? No, we are talking about markings. Marking is a type of device. Okay, still longitudinal. Okay, markings for parking spaces on the side of the road. Those are transverse. Okay, pedestrian crossings. Pedestrian crossings. Those are transverse. Sometimes the road is like you are coming on a ramp. So just before the ramp, they give these lines. Okay, for marking. These are all transverse markings. Then we have object markers and delineators. These are not signs. These are not. Sorry, these are not markings. These are not markings by default, but they are so short that we don't put them in signs as well. Okay, they are not on the pavement like longitudinal or transverse. They are not on the pavement. Okay, unless you go and hit them and they fall. Otherwise, they are not on the pavement. But they are not. They are not so tall that you can put them in signs as well. So we are putting them here just to get rid of them. We have to put them here or here, right? Either in signs or either in markings. Okay, so we have decided we will put them in markings. What are these? This is called as delineators, these orange bars. Okay, and this is called an object marker. Okay, so this delineator is showing you that now this is a space you have to shift your direction now. So you are coming in this lane. Okay, so now you cannot continue. You have to be either go here or go on the other side. Okay, so you will see them near ramps or near the left turn lanes and so on. Object marker, it is denoting or showing an object. What is the object here? This one, the traffic island. Okay, this is the object. So the object marker is showing now there is an object coming in your way. Okay, so stop or go right and left. Clear? Okay. Whenever there is a road closed or something like this, dead end and so on, you see an object marker. Clear? Okay. Then we have traffic signs. Traffic signs can be regulatory, guide, or warning. Regulatory means they are providing information about a traffic law which you have to follow. Okay, and the example is for a speed limit sign. Okay, a speed limit sign is a regulatory sign. Then we have guidance signs which are for directions. Directions to an area, direction to a facility, and so on. So you see this one, direction to an area. And you see direction signs for gas stations, fuel stations, okay, ATMs, hospitals. Okay, so these are all guidance signs. So they are just related to your trip. Okay, they are just for your convenience. Okay, they have nothing to do with traffic laws. Then we have warning signs, which are directly related with safety. Okay, so if there is any danger coming ahead, you want to inform the driver. So one of the dangers I can see here, a very sharp curve. Okay, other thing can be construction work, maintenance work, excavation, whatever. Clear? Steep gradient and so on. Then we have traffic signals. It has the longest list. It has 9 types. Okay, traffic markings has 3. Traffic signs have 3. 3 into 3, 9. Okay, this is how we came up with 9. It was less, then I added some to make the figure. Okay, I'm just joking. The first one is traffic control signals, the ones which we put at the intersections. Okay, at the intersection of the road, the one which we have is called traffic control signals. The other one is pedestrian signal. So pedestrian signals you see in the middle of the road. Sometimes you have a signal, the pedestrian comes, they push a button and then they start going. You will see them in congested areas, okay, Manama, Mohara, Gisa town, Sitra and so on. Okay, and sometimes with the signal you will see the speed hump as well. Okay, just to make sure the car is actually slowing down. Then we have emergency vehicle traffic control signal, something which is done here manually. So a vehicle is coming, emergency vehicle is coming. Okay, so either you see that vehicle, you hear the siren and then you try to give way, right? If there is an emergency vehicle traffic control signal, you will put a sensor inside the vehicle and there is a sensor or a receiver inside the signal. When the emergency vehicle gets close, the signal will detect that the emergency vehicle is coming from this direction. It will turn green from that direction and the directions will turn red until the vehicle has passed. Okay, clear? Then we have traffic control signals for one lane, two-way operations. Again, something which we do manually. Very good. Okay, there is only one lane and we use it for both directions. Okay, we do it very expertly, right? But they are not so good with driving, so we have to put signals for them. So they put a signal on each end of the street. Okay, according to the demand, you can close one end of the street and open the other. So now I need more vehicles from this side, I will close this signal and open the, I need more vehicles from this side, I'll open this signal and close the other side. Okay, so the same street can be used in different timings for different directions. Okay, then we have freeway entrance ramp signals. We call them ramp meters. Okay, we call them what? Ramp meters. What are these? You put signals on the ramp, only for the ramp. People who are entering from the ramp, you put a signal for them. Okay, why do we put them? So to control the flow of the ramp so that it does not distract the people on the highway. Sometimes the flow is so high from the ramp that they keep on entering and the people on the highway have to stop for them now. Okay, there's one guy and they keep on entering. Okay, so a ramp meter or a ramp entrance signal will make sure that after every few seconds the people on the highway have their chance to keep on moving. Okay, so the flow from the ramp is not too much. Okay, whatever number of vehicles we are allowing through the signal is manageable and the highway flow is also moving. Okay, then we have traffic control signals for movable bridges. So you have a bridge which is low height on a river. Okay, and a ship has to pass. So they have to, they open the bridge and the bridge divides into two parts. Not getting it? Don't have any life. Watch movies. Huh? Which city has it? London Bridge. Okay, check it out. Okay, so it's on the Thames River and the bridge is like this. Okay, you can go from one end to the other end. Okay, when the ship has to pass, they'll stop traffic on both sides. The bridge will open like this, the ship will pass and the bridge will close again. Okay, so to do this, because it will take time, right? The opening and closing will take time. So they put a signal here and a signal here. When the ship starts to pass, before the ship comes, they will close the signals. Okay, otherwise, the car is already there and the ship the bridge starts to go like this and then everybody has fun. Okay, we have lane use control signals, which is same as this one but for multiple lanes. Okay, this is common in Europe and US as well. So you have 4 lanes. 4 lanes. On top of every lane there is a signal. We're showing the arrow as well. So now I need 3 lanes for left turning and 1 for straight. So on top of 3 lanes I will see the left arrow. On top of 1 lane I will see the straight. In the morning I need 2 lanes for straight and 2 for left turning. So on top of 2 lanes I will see the left arrow and 2 lanes straight. Okay. So this is for multiple lanes. And then we have flashing beacons. These are flashing lights. Okay, we use them for warning, emergency, and so on and so forth. If construction work going ahead, okay, or I have seen some pedestrian signals as well. They keep on flashing like this. The last one is in roadway lights. You can see over here. So they are put with the markings. They are put with the markings. We want to 1 minute. Yeah. The markings are not clear because of the weather or something else. So you put the lights. So even if the person cannot see the marking, he can see the lights. Okay. So they are on the road with the markings. Clear? Okay. Thank you.